Okay, so it looked like my forum review kind of timed out on me. So this is the third lecture, third part of the lecture for lecture 10, week 5. Again, it's Thursday here of week 5. Let me just drop back into the shell and finish reviewing the forum. So we just finished up embodied energy. Now let's see what if I can catch myself up on landfill practice forum. Ooh, love this stuff. Okay, a lot of replies on the waste to energy. Come on, somebody's got to hop on that art dumpster. And also, here's something I hope I'm making this clear. I would really like to see just about everyone in the class adding a new discussion topic to each one of these forums. You know, I kind of got the ball rolling, but you know, the point of these forums, and this is, you know, really where we come together in this course, is to share your thoughts, share your data, share your plans and proposals. So get your own discussion topics going there. You've got a great chance here in week 5 to do the same thing with glass, and then next week's topic too. So let me hop in here, check out the replies. Start at the top. So, Jason Orshner, just a curiosity question on burning trash. Previously, you've stated that burning plastic is actually better than burning coal due to the lack of heavy metals. Perhaps, yeah, I guess, you know, you when it comes right down to it, I believe I did say that. This being the case, if there was a high quality filtration, would it not be better to incinerate trash and receive some waste to energy benefits than just throwing it in a landfill? Yes, and there are some very fine distinctions, in terms of what burning actually means. And in fact, just yesterday, I was at the Montana Department of Environmental Quality and speaking with the state regulators on incineration, pyrolysis, and gasification. Those are 3 separate sort of breeds of, well, combustion, if you will. But with incineration, it's more or less uncontrolled. You're pumping a lot of oxygen in there. The fire gets very hot. It's very intense. There's very little control over the combustion products versus pyrolysis and gasification, which involve more or less just heating something to their smoldering temperatures. The bonds themselves actually do come apart. Some oxidation does occur, and you end up with waste gases. Again, you're still ending up with a waste gas profile similar but not identical to incineration. A lot of times with incineration, you're getting soot and ash sort of airborne. As I said, much higher temperatures. So, and it's, you know, a whole, we could go into much more detail, but that's more or less the distinction between incineration versus gasification or pyrolysis. So we can pick that up later. But to finish up with your question here, Jason, at least on a chemical to air basis, especially since Missoula does not capture methane and use it for fuel. Yeah, and in fact there are some gasification technologies that will specifically make methane, and some of them being biologically based. I'm really hoping we get to the point where we're able to either use microorganisms that are already present in nature, or do some engineering on microorganisms so that we're able to capture more of that energy as it breaks down, and then just sort of keep that stream going, similar to the chemical looping lab there in Gothenburg, Sweden. I'm not sure if I showed that to you before. I think I might have, but let's just hit it one more time. Chemical looping. Oops. Chalmers. There we go. And again, I don't know a tremendous amount of technical detail about this lab, but my impression is that, well, and you'll see the picture come up, is it's a very sophisticated combustion-based process. I know they've got a lot of catalytic substrates that control how gases flow through this system, and really, putting a lot of intellectual property into the system so that you're extracting the maximum amount of energy and actually, recovering chemically pure, food grade quality materials. And that's, I think that's what we're going to see a lot more of in the future. All right, so back into the forum. So thanks for that, Jason. And so I'm just kind of doing my replies verbally here. New. So let's see. So Rachel, more than 65% of the product from a landfill is usable soil. Whoa. Okay, that's big. In a landfill that is free of toxic waste, the soil can be repurposed for grading roads and other construction projects. Agreed. Yeah. I guess one distinction I want to make is topsoil versus just rail rocky dirt with very low mineral and nutrition content. So, and I've even seen lumps of topsoil going right into the dumpster at the University of Montana. So I guess the overall philosophy here is let's triage that first, rather than putting it into the landfill and then digging it back out later. It just seems like a much more effective way. So 65%, I'd like to see where you're getting that data. That seems a little bit high to me, but I guess I wouldn't be surprised if some landfills see that much soil. Wow. Oh, and I guess when we're on the topic of moving soil around, one of our alumni, Michelle Wallamack, who's at the Belgian embassy in Washington, D.C., has a fellow countryman who's made a living dredging the coastlines of Europe, sort of in preparation for the seas rising. He's taking that dredging material, so again, soil, if you will, that would perhaps, it's got to go somewhere, and he's been making these energy islands out in the ocean. You might have heard about China doing some island building, etc. But what he's been doing is building, and if you've taken NRGY 102, it's sort of an engineered tidal basin or an engineered wave basin where waves come in due to solar thermal effects. They have now a gravitational potential, and then they drain out through a turbine and make electricity. So again, there's another way to repurpose soil. In my area, many people burn their trash in 50-gallon burn barrels. This still leaves behind the residual ash. Sorting the trash before burning can significantly reduce the problem of ash containing high concentrations of various metals. Yeah, I agree. I'm surprised, frankly, that type of garbage burning is even legal. It would be difficult to police it, but yeah, that's really too bad. Okay, Tynan, 4 days ago. Ryan Davis. Okay, Tynan. I had never thought that there was a way to capture energy from burned waste. What happens to items that people throw away that would become hazardous when burned, like mini propane camping tanks? Yeah, I would not ever recommend burning a mini propane camping tank. Once the proper life cycle of that would be to refill it as many times as it's safe. The tanks obviously have a maximum number of times that they can be cycled or stressed, just like an aircraft. You can only fly an aircraft so many times as that cycling slowly builds cracks in the thin wall of the cylinder. Or just due to corrosion, if they're exposed to water or condensation, they might rust prematurely and therefore be susceptible to rupture. But no, you would not burn the mini propane tank. You would simply take the metal and re-smelt it. Okay, aerosol cans, same thing. Paint cans, same thing. All of these things would be more properly disposed of in a metal refining process, not in an incineration. So I agree with you on that one, Tynan. yeah, don't go don't go burning your propane tanks. Yeah, the waste to energy is more focused on organic compounds that contain a high amount of carbon. And the propane tank itself, while you have hydrocarbons inside, the metals are not flammable, at least at conventional temperatures. Okay, although this process, I think in the long run is much more beneficial than burying the trash. Personally, I see more benefits than disadvantages, considering energy is captured and returned in space. Yeah. So yeah, I mean, metals will burn if you, in fact, if you go back to some of the energy density slides that we were looking at on Wikipedia not too long ago, you'll notice that aluminum has an extraordinarily high energy density. So does sodium. So does magnesium. But the way to get those to burn, or in fact explode, is to have them in a fine dust format, so that you have very high surface to volume ratios, thus leading to an explosion. But that's more for incendiary devices, or fireworks or things like that, where metals are used in that manner. Brian Davis. Okay, what kind of trouble are you causing now, Brian? I'm just kidding you, man. I love to kid you. Missoula citizens voted to kill the biomass boiler project at UM. Do you really think they're going to go along with a trash burner? Well, yes, I do. Don't get me wrong. I've long felt that MSW should be a municipal responsibility. It's true, and sometimes, though, private enterprises are better at dealing with it. But I appreciate the sentiment. And should be triaged accordingly. Is if it were a tax-based service, I like to think people would be more conscientious and supportive of practices. I also believe there would be far less blight and random litter strewn about. Yeah, I don't know what to say about the random litter. That's a weird one. I just went for a run here in Billings, like down towards the river, and there was an abandoned lot, and there was plastic, there was glass, a lot of containers just kind of blowing around. And in fact, when I was preparing my talk for yesterday, I started looking at images online for landfills, and man, it was just like a train wreck. I was having trouble finishing putting my talk together. It's extraordinary, the amount of waste that does not end up in a proper disposal unit, whether it's a landfill or some type of waste to energy facility. So, yeah, that's a big one. I think it would probably be better addressed if there were some stricter fines for littering. I don't know what else you do. I've been a friend of James Stevens there at Blue Marble Bio Materials here in Missoula for quite some time, and he said unless you've got the law, money, or some threat of imprisonment or violence against you, a lot of times that people otherwise don't listen. So I know, Brian, you are a very conscientious person, but unfortunately I think a large fraction of our population tends not to think in sort of a long-term sustainability way that we're starting to focus on now here in this class. All right, Taylor, the virtual tour. Okay, does the facility use the power it generates to power its own plant? It would seem a bit counterintuitive based on its principles that a waste-energy plant could be consuming outside energy to power itself. Okay, well, if you're referring to, for example, the facility in Palm Beach, Florida, that I was mentioning before, yeah, if you've got that much embodied energy coming in waste, there is more than enough energy to power the plant itself, and in fact, excess energy to send out to the grid. So I hope I'm answering that question. The metal recycling component seems very viable. Oh, or maybe you're referring to, there was another more advanced Cordovia, if I'm not mistaken, plant that's Well, I think some of them, I mean, I think a lot of them still rely on heavy equipment that has, well, using gasoline or diesel-powered equipment, so obviously that would be more or less primary fossil fuel energy coming in, so that thing wouldn't be entirely powered on garbage, although one could envision a gasification where you would make natural gas and then, or propane even, and power your vehicles with natural gas or propane. Those are fairly mainstream now. Okay. However, we need to address the energy consumed in shipping and reforming the metal as a post-consumer good. Yes, we do. Does it balance out? Well, that's a pretty deep question, and ultimately, no. You know, we're sitting at a very, I think, you know, special time in our civilization where our primary energy sources are running out at a extraordinary rate. If you get a chance, hopefully you'll take a look at the YouTube video that I posted yesterday during my talk to look at the rate at which we're going through this planet's biofuel. It's much more concerning than I had even realized previously in my own work. So, and in terms of cost, that ends up being a very loaded word. I mean, you can just look at the dollars cost, you can look at the environmental cost, you can look at the social cost. And in fact, I was just speaking with a gentleman here at the conference. I've got his business card, I'll just pull it out while I'm thinking about it. Hello. So Cy Gaia is the name of the company, and Gary Gannon was the individual. And what he's been doing is putting together a way of measuring wealth on a much broader scale, and what are the values. So I like the question, but it's tricky to answer that one, and without getting too far afield. One metric that I'm intrigued by is looking at the entropic cost, and it could be that some of these practices of continuing to treat waste could actually have a higher entropic cost to the environment than, well, just putting it in a pile somewhere. It's a great question, though. I really appreciate that, Taylor. Thanks for asking. Okay, emissions are very briefly mentioned, but not detailed well. What type of pollution comes from the incinerator? It's going to be carbon dioxide, and it's going to be perhaps some sulfur compounds, but if properly scrubbed, then they will not, well, we currently do not have a means of fully scrubbing CO2 from any plant. I think it's coming. It's going to take a lot of engineering, a lot of bright people, but I can tell you, though, that Algae Aquatech, which is also here in Montana at the conference, does have one of the world's only carbon-negative power plants. So it's been done on a small scale, and it's going to happen on a much larger scale if we're going to see this stuff succeed. Okay. Again, the energy balance of power to 1 million homes versus the amount of power to run the facility. Give me some numbers. Well, I think I can probably explain that, Taylor. So if you're powering 1 million homes, the amount of power to run the facility is negligible. It might be the equivalent of 10 to maybe 100 homes, and that's going to be true in almost any energy conversion system. So think of it this way: if you see a big coal train moving past, obviously that coal has embodied energy in it. It's got an energy density in it. As that moves by, you can think of that heading off somewhere to be burned in a coal-fired power plant. Now, it does take energy to move that coal. So if the train were being powered by the energy in the coal, what you would see, maybe you left Montana with 100 cars of coal. By the time you got to Seattle, you would only have 98 coal cars left because you burned 2 of them getting there. Very similar thing with your question here. Yes, there's more than enough energy coming in to power that plant. And again, I'm just going to throw something out there. It's going to be probably more than 1% of the energy coming in, and more than likely less than 5%. So more than enough to power the plant. I hope that answers the question. Also, if you have not taken my NRG 101 or 102 courses, you'll realize that energy portfolios really come into play here too. A lot of times, just think about energy flowing into your house. You'll either have electricity or gas. In some instances, some houses will not be on the grid, so there'll be electricity only. And so more than likely, these plants have other, and if they're not making electricity locally, they've got electrical power coming in from the grid. So the future is ours to design on that one. Okay, let me see. Obviously, this is a simplified video made for easy consumption, right? But it would be useful to see the nitty-gritty of the data on such a facility. Would it provide a landslide advantage, or is it a tiny dent in our waste stream? Well, it's probably more or less the latter. However, and if I understand correctly, the country of Sweden is actually landfill negative. I mean, their total waste production stream is likely much smaller than the United States. Maybe you might liken it to Texas, perhaps, but depending on what you think about the size of Texas or Sweden, it can be a pretty big deal if these practices are adopted on a more broad scale basis.
So, yeah, I just think your trash can.
Okay. On whole, it seems to be a responsible turning of post-consumer waste. Creating energy from waste is better than burning the waste in the ground with no abandon. I believe when the Story of Stuff video came out, the buzzword phrase was toxics in, toxics out. What type of pollution are we dealing with here based on the myriad of toxics that get pumped down the consumer's line, and how are they being disposed of? Well, it's another great question. I just had the opportunity last week even to talk with the University of Montana alumni who's doing a plastic pallet repurposing. So he's taking plastic pallets of various types and actually welding them together. He's got one machine that will cut them, another machine that will re-weld them. So he's doing something similar to what we talked about earlier with the glass, keeping the artifact as an artifact. So that is the most, economical way to deal with these type of things. He did mention, though, that there's a lot of arsenic building up in waste streams, and so I asked him, where does the arsenic go? He's like, well, it's just in a bunch of barrels somewhere. It's kind of similar to what we do with our radioactive waste. It's just kind of hanging out in barrels till whenever. And unfortunately, I don't think we have an answer. It's one of those things that's sort of in stagnation. So again, I think you always in any waste scenario have a couple fundamental options. One is to concentrate it, and the other one is to disperse it. And I'm thinking in the case of arsenic that concentration is probably better than dispersal. And it could be that down the road we repurpose some of our deeper mines for sequestering that material. And that's all. That's kind of my 2 cents on it. All right, well, I'm going to take another quick break here and be right back.